boy Tashon.
All right, welcome again, guys. Today we are going to be looking at properties of the periodic table. And again, these are the standards for the North Carolina 8th grade science. All right, so let's begin. So, first, we need to ask ourselves some questions. So, these are the questions that we're going to be looking at. So, the first one is we're going to be looking at what is the periodic table and how is it arranged. Number two, how to obtain information about atoms. Let me move this other way. Atoms such as the subatomic particles. Number three, what are the properties of a group and a period? Number four, how are groups arranged? And then we're going to be looking at some example questions. All right, so let us begin. So, the modern periodic table, this is how it is arranged, right? This is what you would see when you go in the EOG or your end of year exam. You'll be getting one of this, and don't be afraid to use it. So, this is exactly how the modern day periodic table is. Let's answer question number one. What is the periodic table? So, the periodic table is a list of all the known elements. The periodic table is a list of all the known elements. How is it arranged? So the periodic table is arranged in increasing atomic number. In increasing atomic number. Okay? So that is how the periodic table is arranged. Now, what we're going to be looking at, we are going to be zooming in on one of those small boxes on the periodic table. In those small boxes, you will see a letter. That letter represents the symbol. That letter represents the symbol. If I could just focus right here so you can see it, right? This letter represents the symbol. We will also see the atomic number. So the atomic number, it can either be at the bottom or it can be at the top. But here is how you remember the atomic mass. I meant the atomic mass. Here is how you're going to remember the atomic mass, right? It is the larger number. So the larger number is the atomic mass, while the smaller number is the atomic number. Now, the atomic number is the counting number. All right, wonderful. All right. Now, let us look at let's zoom in on a box on the periodic table. Now, let us zoom in on a box, one of those small boxes on the periodic table. If you see those boxes, we have a symbol, right? Now, the letter represents the symbol. The letter must begins with a capital letter, all right? So this letter that we see here is C. It represents carbon. We can also see on those boxes the atomic mass. The atomic mass is the larger number, okay? And we can also see the atomic number. The atomic number is the counting number. Wonderful. Let's now look to see if we can identify subatomic particles by knowing the atomic mass and the atomic number. So first, I am going to draw the symbol. What does the symbol represent? It represents carbon. Okay? What is that? That is the mass number. And the 6 is the atomic number. So the larger number is the mass number, And the smaller number, which is the counting number, is the atomic number. As I said, we can always remember the mass number because it's the larger number, okay? And the atomic number, as we are going to see now, it is the smaller number. So that would equal to 6. Wonderful. Now let us look to see if we can find the subatomic particles. This first subatomic particle is proton, and the proton is equal to 6. Yes, it's the same thing as the atomic number. The second subatomic particle is the electron number, and the electron number is 6. It is also equal to the proton number. Therefore, what can we say? What can we say? Therefore, here's an abbreviation. Therefore, P, which is for protons, E, which is for electrons, and A, which is for atomic number, all equal the same. So PEA, proton, electron, and the atomic number all equal the same. How do we find the third subatomic particle, the neutron number? The neutron number is the mass number minus the atomic number. Wonderful. So that's 12 minus 6, and that would equal to 6. Awesome. Let's now try one on our own. You can pause the video and let's try one on our own. The element that we are looking at must begin with a capital letter, L, I. That's lithium. And the mass number is 7 and the atomic number is 3. So here we go. Mass number equal what? You should know, 7. The atomic number equal what? You should know, 3. Wonderful. So let's find the subatomic particles. The proton number is equal to the what? Should equal to the atomic number, 3. The electron number is equal to what? Proton number, which is 3. And now let's find the neutron number. The neutron number is equal to what? The mass number minus the atomic number, which is 4. 7 minus 3 equal 4. And there you have it, guys. That's how you calculate the subatomic particles of elements on the periodic table. Now, let us look at properties of the periodic table as it relates to groups and periods. So let's first begin with groups. Here is it. Groups are divided into different categories. But the categories that you guys should know is 1. Groups are metals, non-metals, transitional metals. Okay? And you have noble gases. All right. That is on your standard for grade 8. Group 1 and 2 are called metals. Groups 13, 14, 15, 16, 17, 18 are called non-metals. Groups 3 to 12 is called transitional metals. But watch this. I need for you to get this. I'm going to write something here so that you guys can see it. Okay? I'm going to write something that you guys can see it. Now look at this. Let's go back. And what I'm going to do is I'm going to focus here. So groups 1 and groups 2 are called metals. Groups 13, 14, 15, 16, 17, 18 are called, well, not 18, 17 are called non-metals. Group 18 is called noble gases. And groups 3 to 12 is what? Transitional metals. Now, these are the properties. All elements in the same group have similar properties. They react most likely the same way. So all elements in group 1 here react the same way. All elements in group 2 react the same way. All elements in group 13, all elements in group 14, 15, 16, 17, 18, they react the same way. Here's another property. The most reactive elements in the metal side, which is group 1 and 2, are the ones at the bottom. So the elements that are at the bottom of the periodic table for groups 1 and 2 are the most reactive. So therefore, the most reactive element is at the end of group 1. Let's go over to nonmetals. The most reactive nonmetal is at the top of group 17, right? So most reactive metal at the bottom of group 1. Most reactive nonmetal at the top of group 17. Wonderful. The shells or the periods. So the periodic table also have periods. We have 7 periods on the periodic table. So here we go. What does the period tells us? The period shows that as you go from left to right, you see that the atomic radius gets bigger. We have more electrons getting onto the shells on the periodic table. So, as you can see, let's look at lithium. This is period 2. You see, lithium has 1, 2, 3 electrons. Look what barium has. 1, 2, 3, 4. Beryllium, sorry. Look what boron has. 1, 2, 3, 4, 5. You see, as you go across, the atomic radius increases and the number of electrons increases. Good. Another thing, the periodic, the groups also tells us the valence electrons. The group also tells us the valence electrons. Okay, so here we go again. The group tells us the valence electrons. So what's the valency for group 1? 1. That means it has 1 electron on its outer shell. Group 2, it tells us what? The valency for group 2, which is 2. It has 2 electrons on the outer shell. The valency for group 13 is 3. It has 3 electrons on the outer shell. The valency for group 14 is 4. It has 4 electrons on the outer shell. For group 15, 5. Group 16, 6. Group 17, 7. And watch this, group 18, 0. Yes, group 18 is also called group 0, right? That means the valency for that group is 0. It does not need any more. But as you go to high school, you learn more about valencies. Now, let us look at how the periodic table is with groups and periods. As you can see on this periodic table, you see that we have uh, 7 groups and group 0. Now, these are called the main groups. So group 1 is called a main group. Group 2 is called a main group. Group 3 would be called group 13, right? But we are going to say group 13 is called group 3, a main group. Group 14 is called group 4, a main group. Group 15 is called group 5, a main group. So in general, we have 18 groups, but we have 8 main groups. And we have 7 periods. Let's now look at some questions that you might see. How are elements similar to those in the same group on the periodic table? And as you can see, the answer is A. They have the same number of valence electrons. So as we said earlier, Once you are in the same group, you have the same valence electron, you react similar, okay? You have the same valence electron and you react similar. Good. Here's question number 2. Which choice best describe the properties of potassium based on the position on the periodic table? And if we should go back, potassium is K right here. Potassium is K. That's in group what? That's in group 1 of the periodic table. So what does the question say? Which best describe the properties of potassium based on the position on the periodic table? And the answer is B, a highly reactive metal. What did we say about the reactivity? As you go down the group, as you go down the group, it gets very reactive. And groups 1 and 2 are called metals. So it could not be, the answer could not be D because it says what? Non-metals. The answer has to be B, highly reactive metal. Question number 3. Where are the most reactive metals located on the periodic table? Here we go again. Where are the most reactive metals on your periodic table? What did we say? The most reactive metals are what? At the bottom of the periodic table. The most reactive nonmetals are to the top of the periodic table. So F is the most reactive nonmetal and Fr is the most reactive metal. So let's see. Where are the most reactive metals? The answer is C, the column at the far left side of the periodic table. Question number 4. Where are the most non-reactive? Uh, where are the most reactive non-metals located? What did we say? It is the what? Second column from the right. Wonderful. Look at your periodic table and identify the second column from the right. And the last question, which characteristics of an element determines its placement on the periodic table? What did we say again? The atomic number tells us where the where the atom is on the periodic table. The atomic number tells us where the atom is on the periodic table. Now, what is also equal to the atomic number? Because we do not see the atomic number in this question. But what is also equal to the atomic number? The number of protons. Okay, guys, there you have it. Stay tuned for the next video. We are going to be talking about how can we draw the atomic structure, and we are also going to be looking at balancing chemical equations. Bye-bye.